Open your fridge right now and count the blue things inside it. Go ahead. Look at the fruit, the vegetables, the meat, the leftovers. You will find red, orange, yellow, green, brown, purple, white, and almost certainly not a single thing that is truly naturally blue. This is not an accident of your shopping list. Across the entire world, blue food is astonishingly, almost impossibly rare. Nature paints itself in every other color with wild abandon, and then, when it comes to blue, it nearly gives up. So here is a question you have eaten your whole life without ever asking. Why is there almost no blue food? The answer is not marketing, and it is not taste. It is a strange story hidden inside the physics of light and the chemistry of living things, and by the end, you will never look at a blueberry the same way again. And yes, let us deal with the blueberry immediately, because it is about to betray you. You are probably thinking, wait, blueberries are blue. Case closed. So take a blueberry and cut it in half. Look at the inside. It is not blue. It is a deep purplish green. The blue you see on the outside is a thin skin, dusted with a pale, waxy coating, sitting on a pigment that is not really blue at all. The blueberry is wearing blue on the surface, but it is purple all the way through. And that little lie is the doorway into the whole mystery. Because to understand why blue food barely exists, you have to understand something bigger. Blue is one of the rarest colors in all of nature, not just on your plate. Blue flowers are uncommon, blue animals are even rarer, and the reason comes down to a brutal little rule of physics. Color is created when a material absorbs some wavelengths of light and reflects the rest back to your eye. For something to look blue, it has to absorb red light, which sits at the low energy end of the spectrum. And here is the problem. Absorbing that specific low energy red light is chemically very difficult. It requires unusually large, complex, and expensive molecules to pull off. For a plant, building a true blue pigment is like being asked to build a cathedral when every other color only needs a shed. Most living things simply never bother. It is too much effort for too little reward. So when you do see something blue in nature, something is usually up. And this is the reveal that changes everything. A huge amount of the blue you see in the natural world is not a pigment at all. It is a trick of light. Think of a brilliant blue butterfly wing or the shimmering blue of a peacock feather. If you ground those up into powder, the blue would vanish, leaving behind dull brown. Because there is no blue paint in them, instead, their surfaces are covered in microscopic structures, tiny ridges and layers thinner than a wavelength of light, arranged so precisely that they bounce blue light back at your eyes and cancel out the rest. It is not color, it is architecture. The blue is built, not painted, and a fruit cannot easily do that. A soft, edible berry cannot grow a microscopic mirror. So the plants that manage to look blue at all have to cheat in a different way, and this is where it gets even stranger. The pigment that makes most blue foods possible is a family of molecules called anthocyanins. These are the same pigments behind red cabbage, purple grapes, and the skin of that blueberry. But anthocyanins have a wild property. They change color depending on how acidic their surroundings are. In acid, they turn red. In neutral conditions, purple. And only in alkaline conditions do they finally shift toward blue. You can watch this happen in a kitchen. Boil red cabbage and pour the purple water into something acidic like lemon juice, and it flushes pink. Add something alkaline like baking soda, and it turns a deep blue-green. So the very pigment that could make food blue is a chameleon that refuses to hold still. Most fruits are slightly acidic, which pushes anthocyanins toward red and purple, not blue. Nature was handed one shot at making blue food, and it was given an unstable pigment that turns the wrong color in almost every fruit that exists. And yet, a tiny handful of foods do manage it, and how they do it is beautiful. There is a flower from Southeast Asia called butterfly pea, whose petals brew a tea of an almost electric blue. But squeeze in a little lemon, and right in your cup, it turns purple, then pink, revealing the same restless chameleon pigment underneath. There is blue corn, and there are blue potatoes, both leaning on anthocyanins tuned just right. And there is a mushroom, the indigo milkcap, that bleeds a startling blue when you cut it. But notice how short that list is. In a living world overflowing with millions of species and every shade imaginable, the truly blue foods can almost be counted on your fingers. They are not the rule. They are the rare, hard-won exceptions that prove just how difficult blue really is. Now layer on top of that a second, sneakier reason. It is possible that we are actually wired to be suspicious of blue food. Think about it from the perspective of survival. For millions of years, the things our ancestors could safely eat were red, orange, yellow, green, brown, ripe fruit, fresh leaves, cooked meat. Blue and purple, on the other hand, often signaled something was wrong: mold, rot, spoilage, or a warning color on something toxic. So, a brain that felt a flicker of disgust at a blue meal might have been a brain that survived a little longer. To this day, food scientists know that dyeing food blue can suppress people's appetite. Blue is the color of the poisonous, the spoiled, and the artificial, sitting deep in the back of your mind. So we have a perfect storm against blue food. The physics makes blue pigment extraordinarily hard to build. The one pigment that can do it is unstable and usually turns red or purple instead. And our own instincts may quietly push us away from blue food even when it appears. Which raises one last, very human question. If nature almost never makes blue food, then where on earth did blue raspberry come from? Because you have definitely eaten something blue. A blue slushie, blue candy, a blue sports drink. And here is the punchline. All of it is fake. There is no such thing as a blue raspberry. It was invented. Real raspberries are red, and so many candy flavors were already fighting over red that manufacturers needed a new color to tell them apart. So they reached for a lab-made dye, most famously one called Brilliant Blue, and simply assigned it a flavor. Blue is not the taste of any fruit. It is the taste of human beings deciding to fill a gap that nature left empty. We wanted blue food so badly that, unable to find it in the world, we manufactured it ourselves. So, why is there almost no blue food? Because to be truly blue, a thing must absorb red light, and that takes molecules so large and costly that life rarely builds them. Because the blue we do see in nature is often an illusion of structure, a mirror too fine for a soft fruit to grow. Because the one pigment that might save us is a chameleon that turns red in the acidic world of most fruit. And perhaps because, somewhere deep in our evolutionary memory, blue food still whispers a quiet warning. The next time you spot something blue on a plate, stop and really look at it. It is almost certainly a trick, or a chemical, or a lie. Because blue is the one color the living world never quite learned how to make, and the one we wanted so badly that we built it ourselves.